Hey, what's going on, guys? Welcome back to another video. Today we are simply just going to be looking at some practice problems for our half and our double angles. Now, these can get particularly confusing. They can get really long. I'd expect this video to be about half an hour, even with cuts and speeding up me doing work and stuff like that. Regardless, check the description or check just like the little red bar at the bottom. I should have timestamps for you guys for each question. With all that being said, if you haven't seen the double or half angle formula video, check it out. It's in the description below. And let's just get right into it. First, we have 2 cotangent 2x is equal to cotangent x minus tan x. Now, first thing I'm going to do, split it up into left side, right side. On the right side, we have cotangent x minus tan x. And on the right side here, we have 2 times, I'm just going to rewrite it as 1 over tan 2x, just like that. Now from here, this 2 can actually go up top, so this can become 2 over tan 2x, just like that. And from here, what I'm actually going to do is I'm just going to rewrite it as 2 divided by tan 2x. Whoops. I'm just going to write it like this. And you'll see why in just a moment. So now we're going to change our tan 2x. We know it becomes 2 tan x over 1 minus tan squared x, just like that. And the reason I did this is because now we can turn this into a multiplication by flipping. So it becomes 2 times 1 minus tan squared x over 2 tan x, just like that. Now these 2's can cross out, and we are left with 1 minus tan squared x over tan x, just like that. Now from here, what I'm going to do is I'm just going to break it up. This becomes 1 minus tan x minus tan squared x over tan x, just like that. Right? Same denominator, the tops just subtract, that's how we do it. Well, from here, this can cross out, and that's the same as saying cotangent. I'm actually going to write it over here. So we get cotangent x minus tan x. Left side, right side equal, perfect. Therefore, QED. Let's move on to the next one. Okay, moving on to the next one, we have 2 cosecant of 2x is equal to secant x times cosecant x. Right side, left side. Here, I'm just going to change this to 1 over cos x times 1 over sine x, and then that can just simplify to 1 over cos x sine x, just like that. And here, on our left side, we have 2 times 1 over sine 2x, just like that. 2 can multiply through, so we get 2 over, and sine 2x, well, we can just change it, right? We know what it is. It becomes 2 sine x cos x. And would you look at that? The 2's cancel out nicely. We are left with 1 over sine x cos x. Both sides are equal, therefore QED. Let's move on to question number 3 now. Okay, now moving on to question 3, this one is a little bit different because here we have our first half angle. Now, the way we deal with half angles is a little bit different than the way we deal with double angles, but overall it's like basically the exact same. So, I know that didn't make any sense, just stay with me. Basically, here, we have x over 2, right? Let's set this equal to any variable, let's say a. Perfect. And now let's rewrite everything using a. Here we have 1 plus cos of 2a divided by sine of 2a. And on this side we have cotangent a, right? Now if I lost you there, think about it like this. 2a, and we know a is equal to that, so it becomes 2 times x over 2, which is just equal to x, right? So writing it as 2a just like that, and writing this as a, now we can solve this, right? we can use our double angle formulas and we can figure this out. And that's essentially how we do our half angle formulas. Or sorry, our half angle trig identities. Instead of turning this one into something else, we actually just end up turning these into doubles. And the reason we do that is because if we turn this one into its formula, or sorry, its equation, we get a square root, which we don't really know how to deal with, right? When it comes to solving identities, we can't really do anything with that. So the way we do it is we turn the other side into doubles. Now, with that being said, let's continue on with the question. And later on in the video, like with other double angles, instead of using a or something, I'm just going to use 2x equals x. Essentially, I'm going to multiply everything by 2, all the x's by 2, sorry. But let's keep going. So now this can become, I'm going to change the 1 into sine squared x plus cos squared x. And cos 2a, which is essentially just x, really. So actually, I'm just going to change that now. Just like that. And essentially, the reason I did that is because I multiplied all the x's by 2. Anyways, cos 2x is equal to cos squared x minus sine squared x. And we're dividing this by 2 sine x cos x. Perfect. Now from here, sine squared x minus sine squared x cancel out, and that becomes 2 cos squared x over 2 sine x cos x. Just like that. 2's cancel out, cos squared x and cos x cancel out, and this becomes cos x over sine x, just like that. And well, we know what that is. That is just equal to cotangent of x. Now, cotangent of x and cotangent of x are equal, right? Therefore, QED. Just like that. Now, this has to be equal to this. This is never going to be equal to that because what we did is we multiplied all the x's by 2. It's a bit of a tricky step, but once you understand it, it all seems to make sense. Cos 2x right away, let's change these into what they are. This becomes cos squared x minus sine squared x divided by 1 plus, and this can be 2 sine x cos x, just like that. Now here we have a compound angle, and what we're going to do is just that. We're going to use our compound angle formula. So this will become tan pi over 4 minus tan x divided by 1 plus tan pi over 4 tan x. Now, tan pi over 4 is just 1. So this just becomes 1, and that becomes 1. So we get 1 minus tan x divided by 1 plus tan x. Now, from here, what we actually do is, well, we can do one of two things. That answer right there is given to us in coses and sines. And, well, we can actually sort of just do that. So what we're going to do is I'm actually going to rewrite it first. Just like that. And from here, we're just going to change our 1's into cos over cos and our tans into sine over cos. Just like that. Now, here, we get cos x minus sine x over cos x, and we're basically multiplying by cos x over cos x plus sine x, just like that. Well, that can crisscross, and we get cos x minus sine x over cos x plus sine x, just like that. Okay, so now from here, basically all we're going to do is we're just going to multiply this by 1, essentially. And you'll see what kind of 1, but what we're going to do, and I'm going to do it in red so you see like what I'm doing. we're going to multiply it by cos x plus sine x, just like that. Okay, just like that. So that over that equals 1. We're allowed to do this. And you'll notice the top actually becomes a perfect square. And I'm going to erase this and move it up at the top. As I was saying, the top actually becomes a perfect square. Here we have a minus and here we have a plus. So that basically just gives us cos squared x minus sine squared x at the top. Now the bottom is actually a perfect square, not a difference of squares. And basically, if you know the equation, if you don't, you can just FOIL it. But if you do, you can just jump. You can say it becomes cos square x minus 2 sine x cos x plus sine squared x. Just like that. And something else you'll notice is that cos squared x plus sine squared x actually gives us 1. So from here, we just finished. We get cos squared x minus sine squared x over, now cos squared x plus sine squared x equals 1. 1 minus 2 sine x cos x, just like that. Those are equal, therefore QED. Now let's move on to the next one. Alright, moving on to the next one, I'm going to rewrite secant and I'm going to expand that using the compound angle formula. Okay, now from here what I'm going to do is I'm going to basically rewrite that, and tan pi over 4 becomes 1, so I'm going to simplify that. Okay, my next step is now we have x over 2, and like we did before, essentially all we're going to do is multiply all of them by 2. So multiply that by 2, and then this by 2, and that by 2. And I'm just going to rewrite it. Okay, just like that. Now from here, we can start using our double angle formulas to start working with that. So let's get to that. 1 minus, I'm actually just going to rewrite the 1 as well. Okay, now from here, hopefully you guys noticed that this looks kind of familiar. And I changed the 1 into sine squared x plus cos squared x so you could see that this whole thing can actually become a perfect square, right? We have sine squared x, we have 2 sine x cos x, and we have cos squared x, right? Simply by putting the sine squared x or the cos squared x there, we have a perfect square. So that's exactly what I'm going to write it as. This just becomes cos squared x, or sorry, cos x minus sine x squared. And the bottom stays the exact same, cos squared x minus sine squared x. Now, on this side, let's start working with it a little bit. Okay, so what I just did, I turned the 1s into cos over cos and the tans into sine over cos. Just like that. Now these can crisscross and we get just like that. And once again, like we did in the last one, now this time we want the perfect square on top, so we're going to multiply by cos x minus sine x over cos x minus sine x. Now the bottom is actually a difference of squares, which gives us that basically. And the reason I'm writing this in red is because I'm trying to show you that we're multiplying by 1. So this then equals just like that. Now we have our identity, it's proved. So therefore QED. Let's move on to the next one. Okay, now here is a little bit of a longer one, and I'm actually just going to speed up the next couple minutes of me working through it. But basically what I'm going to do is I'm going to expand the cos 2x's and the sine 2x's, and I'll simplify and then I'll get back. I'm also going to change all the 1's into cos squared x plus sine squared x. Okay, now from here, cos squared x minus cos squared x just zeroes out. Sine squared x plus sine squared x becomes 2 sine squared x, and that stays as plus 2 sine x cos x. Now let's look at the bottom. Sine squared x minus sine squared x cancel out. Those two zero, and cos squared x plus cos squared x becomes 2 cos squared x plus 2 sine x cos x. Now from here at the top, we're going to factor out 2 sine x, right? Because it's a common factor. And at the bottom, we're going to factor out 2 cos x. And right away, we see two things. Well, first, the 2's can cancel out. And these two brackets are the exact same. And since they're being multiplied, well, we can crisscross. My bad. Anyways, from here, we are left with sine x over cos x. Well, which we know is tan x, just like that. Now, left side, right side, are they equal? Yeah, they are. So, therefore, QED. Let's move on to the next one. Okay, now this next one can get very complicated. It can be very long, that's for sure. If I show you my sheet, it's very long. But the trick is with it, and the reason this one is so different is because here we have a 5x instead of a 2. And if you saw the deriving the double and half angle video, which I'll leave in the description, then you kind of know how to tackle this. Now, with that being said, this one will be very, very, very long. A lot of simplifying, a lot of stuff like that. So I'm just going to speed it up, but feel free to pause it or slow it down or anything like that. With that being said, I'll just show you guys how to change that 5x real quick. So if you did see the video, you would know that essentially that is what we would do. And then from here, we'd use our compound angle formulas. And we do the same for 3x to get x plus 2x sort of thing. You'll see it in the upcoming footage. With that being said, I'm just simply going to work on the left side alone right now. And I'm going to use colors too, just so I don't lose track, because brackets are very important, everything like that. One wrong step and it'll all be messed up. So let's keep going. Okay, so now from here, all of our double angles, I'm just going to change them into what we know. Okay, now from here, inside the brackets, just check to see if we can simplify anything. Right there, that can become minus 3 cos x sine squared x, and over here, this can become plus 3 sine x cos squared. From there, let's keep it going. I'm just going to erase this and rewrite it at the top. Okay, and now what I'm going to do is I'm going to multiply that through to that and that through to that. Okay, now from here, we're just going to find like terms. So 3 sine x cos 4x and positive 2, so that can become 5 sine x cos 4x. So we added those two. Cos squared sine to the 3. So here we have negative 1 minus 3. Cos squared. Oh, negative 1 minus 3, so negative 4 minus 6, so negative 10. Sine 3x cos squared x. So we took care of those, and finally we have sine to the 5x. So plus sine 5x, just like that. So now from here, essentially what we're going to do, we can leave it or we can factor it, anything like that. But don't forget, we're solving an identity. We want this to equal that side. So I'm just going to go ahead and leave it like this because this is the most fully expanded form we can get. Now I'm going to write this off at the bottom or something, and we're going to start working on the right side. Okay, so now moving on to the right side, all I did really was change the cos squared 2x and sine squared 2x into just multiplying by itself. Now from here, once again, all we're going to do is simplify, keep your brackets, keep your addition, your multiplication, make sure it's all A-okay, I guess. Let's keep going. Okay. Now from here, essentially what we're going to do, we can see that that can simplify, and we're going to basically expand out this bracket. So we get this to equal and I'm also just going to multiply the 2 cos x through. So this then becomes, so once we multiplied that through, sorry, the camera cut out and I erased everything, so I have to write it back. But anyways, now that we've done that, I'm going to move this up to the top, and this blue section here, we're going to find like terms and we're going to simplify it. Then we're going to run the sine x right through it. Just like that. And now finally, our final step is to look at this, and once again, we're going to collect like terms. So sine x cos 4x can be added to that, so that can become 5 sine x cos 4x, just like that. We have 6 cos squared sine to the 3, negative 6, and we have negative 4. Sorry, there's a minus. I should have wrote it down here. There we go. So minus 6 minus 4 becomes negative 10 cos squared x sine to the 3x. And finally, plus sine to the power of 5x. Now, when we look at this and we look at our left side, are they equal? Yeah, they are. The only thing is that this one just has it flipped, but that doesn't matter because it's multiplication. Besides that, these are the same thing. So therefore, QED. After all that work, we finally got this question done. Let's move on to the next one. Okay, moving on to this next one, we have 4 times cos 6x, cos to the power of 6, I should say, plus sine to the power of 6x equals 1 plus 3 cos squared of 2x. So I'm actually going to work on the left side first. Now, they're cos to the power of 6, which isn't necessarily what we want. We want it as reduced as we can, because when it comes to cos to the power of 6 or plus sine to the power of 6, there can be a lot of combinations to give us that. So we'd rather reduce it than try to figure out the combinations to go up to it. So with that being said, we're just going to change this to cos to the power of 2x times cos to the power of 4x plus sine to the power of 2x times sine to the power of 4x. Just like that. And now from here, we're basically going to change our coses and our sines, and we're going to expand it, and we're going to kind of do that a few times. Okay, so I changed the cos squared to 1 minus sine, and I changed the sine squared to 1 minus cos. So let's keep it going. This becomes 4 just like that. Sorry about that. From here, basically the cos 4x and the sine 4x, we're going to do the exact same thing to them, as well as these two right there. Okay, just like that. And now from here, we're going to take this whole giant thing and we are going to collect like terms. Okay, so simplifying, we have minus cos square sine square minus another sine square cos square, so we're at -2. And then let's see, minus a third, so we are at -3. And we are at -4 sine squared cos squared x. Okay, now finally we're left with this right here. After we simplify, expand, everything like that, what I did earlier was I changed that sign to the 4x into sine squared x times sine squared x, and I changed one of the sine squared x's into 1 minus cos squared x. Now here, cos squared x plus sine squared x equals 1. So we get 4 times 1 minus 3 sine squared x cos squared x, just like that. And I'm going to go ahead and leave it at that for the left side. Now let's do the right side. Okay, essentially what I just did was I jumped a couple steps, but overall you should understand. That right there, I just FOILed it out. The cos 4x, I rewrote it essentially as cos squared x times cos squared x, just like that. And I took one of the cos squared x's and turned them into 1 minus sine squared x. And then I multiplied through, so cos squared x times 1, cos squared x times negative sine squared x. And I did the same for the sine 4x. So, moving on from there, let's collect our like terms. Cos squared x plus sine squared x becomes a 1. Negative cos squared x sine squared x minus 2 becomes -3. Minus another one becomes -4. So we get 1 plus 3. We have 1 minus 4 cos squared x sine squared x, just like that. And let's expand out the 3. So we get 1 plus 3 minus 12 cos squared x sine squared x. All I did was run the 3 through. From there, 1 plus 3 just gives us 4. So we get 4 minus that. And from here, we can actually factor out a 4. So if we factor out a 4, we get 4. 1 minus 3 cos squared x sine squared x, just like that. And left side, right side are equal. Therefore, Q, E, D. Let's do the next one. Okay, moving on to this one, we have sine 2x divided by 1 plus cos 2x equals tan x. Now this one's actually pretty simple. We're just going to change our sine 2x, our cos 2x. We're also going to change the 1 into sine squared x plus cos squared x, and you'll see where it goes. And all that is equal to tan x. Therefore, hold on, make sure you write right side tan x. Therefore, Q ed, just like that. Now, if you're confused on what I just did, I expanded those two, and I changed the 1 to sine squared x plus cos squared x, and simplified. Sine squared x minus sine squared x zeroes out. That's the same, so it becomes 2. The 2's can cross out, and a cos squared is basically just becomes cos, and that one crosses out. We're left with sine over cos, which becomes tan. Let's move on to the next one. Okay, moving on to this one. We're going to work with the left side first. Now, you might be tempted as soon as you see the x over 2 to switch it right away. But let's simplify first and then let's switch it. Oh, my bad, I made a mistake. This should be a multiplication. Just like that. My apologies on that. So I'll change it here as well. Keep going. Okay, so now from here, now that I've simplified this side as low as I can right now, now at this point is where we're going to actually take the x's and multiply them all by 2. And the reason we do that now and not earlier is because if we did it earlier, as you can hopefully see, it would have been a lot harder. It would have been a lot more steps, a lot more work, and we don't want that. We want to make it as easy as we can. So now we're going to multiply all our x's by 2. And hopefully you guys see this, but this is the exact same one as was up there and the one in the previous question. So I'll just go through the steps anyways, but hopefully you guys can skip from that straight to 10x. Just like that. So therefore, Q, E, D. Now let's move on to, I believe, the last question. Yeah. Okay, on to the final question. Cos to the power of 6x minus sine to the power of 6x equals cos 2x times 1 minus 1 over 4 sine squared 2x. I'm going to go ahead and work on the left side first. And what I'm going to do is I'm going to break up the cos to the power of 6x and the sine to the power of 6x. And I'm going to keep doing it until all I'm left with is squares and I think thirds it is. Or sorry, cubes. No, sorry, squares and to the power of 4. But basically the way I do that is I split it up and you'll see. Okay, and we're just going to leave it at that. And I'm going to write it down here. So left side is equal to cos to the power of 4x minus sine to the power of 4x minus sine squared x cos to the 4x plus sine to the 4x cos squared x. I'm going to just do that. And now let's take a look at the right side. Okay, now from here, once again, collect like terms. So cos 4x minus sine 4x, dealt with that. Sine squared x, cos squared x, minus sine squared x, cos squared x, that zeroes out. And here we have, let's see, negative minus sine squared x cos to the 4x, and here we have positive sine to the 4x cos squared x, just like that. We did it. that is equal to that. So therefore, QED. Now that's basically going to sum it up for this video, guys. I hope you enjoyed. I hope you understood. I hope it helped in any possible way. This is probably the most amount of time I've spent on a video. Probably because of that one question alone. Like 30 minutes of actual footage. Anyways, guys, hope you have a great day. If you have any questions about any math, physics, anything like that, leave it in the comments below or text me personally. I'll be happy to make a video about it. Check out any other videos if you need help. That being said, have a great day. Peace.